Alright, so this is video A9. Of course, you'll have a quiz on this tomorrow, and we're on the first one, which I took a picture of the different number sets up there for us, and I'm going to do number 7, which is 17/5. So if you see, guys, just by looking at this, they're all real numbers. Every single one of them that we're going to deal with is a real number. So the real numbers then break off into, rational or irrational. Irrational is just like the word says. Irrational means kind of like illogical, doesn't make sense. So those are numbers that go on forever, are square roots that aren't perfect squares, so they go on forever, and numbers like pi, which also, goes on forever. Okay, if it doesn't fall into this category here, it falls into a rational number. And a rational number means that at some point it ends or it repeats. So, my fractions, my decimal numbers that repeat, and they can be positive or negative. An integer is positive or negative or 0, but it doesn't have any fractional or decimal point. It is just, it is positive, 0, or negative, but it doesn't have any fractional point part or any decimal part. If it's an integer, it is also rational and it's also real. Whole numbers is a subset of integers. A whole number just means that it can't be negative. So it's the integers, but only the non-negative. So it starts at 0 and goes 1, 2, 3. Once again, notice there's no fractional part and there's no decimal part. Every whole number is also an integer, it's also rational, and it's also real. Natural numbers are called natural because it's the natural way we count. We go 1, 2, 3, etc. So you'll notice that it is all positive numbers that have no decimal or no fraction. So it looks just like the whole numbers, except the whole numbers contain 0 and the naturals don't, because we don't naturally start counting with the number 0. So we have anything that's a natural is also whole, it's also an integer, it's also rational, and it's also real. So let's take a look at 7, which is 17/5. So I'm going to start with the smallest set. So I'm going to start over here and see which way it goes. Well, obviously, it's not natural. I don't count. Oh, look, I have 17/5 oranges, right? It has a fractional part here. So I know it is, I know it is, let's use a different color here. I know it is not natural. Okay. So then I look at the next set, and I see, whole numbers. Well, once again, there's no fractional part, so I know that it is not whole. Okay, I'm going to look at the next biggest set, and that is the integers. Well, if I look, there's no fractional part. They're positive and negative and 0, but they have no fraction. So I know, again, it is not an integer. So I'm going to come on to the next one, right? And take a look at that one, and that's rationals. Well, rationals kind of make a big jump, right? So rationals are numbers that end, or repeat. So I look and I see there are fractions in there. So now I know, in fact, that it is rational. So it's rational. And then I look at anything. Now that I found the first set that it begins with, I look at anything that's to the left here, and it has to be real. Every single number we deal with will, in fact, be real. So these are the two sets that 17/5 belong to, rational and real. And once again, it doesn't belong to any of these, because these don't have fractions. So the fraction kicks us out of those 3. Okay, so when it comes time for your quiz, I'll probably ask you, oops, that's not what I wanted. I'll probably ask you why 17/5 isn't I said it wasn't natural. I said it wasn't whole. I said it wasn't an integer. And I'll ask you, why did I say that? And you would tell me, because it has a fractional part. And natural, whole, and integer never have any fractional or decimal spot. Okay? That's it for that one. All right, guys, so now this is, oh, shoot, that's a mistake. This is still a 9. That was, wishful thinking by me. So this is still a, anyway, this is, I don't know what's going on. I'll make that a 9. That's a 9, A9 continued, and it's a, I need an example of a negative number, a negative integer. So, the first thing I'm going to do is take a look at what makes up my integers. They're right there. Just for fun of it, I'm not going to copy one that's in the little box. I'm going to say it's negative the square root of 36. Now this is a little bit clever because it has a square root, and if we look here, right, we see that when we have square roots, they fall under irrational, which there's no connection to the integers. So that's kind of funny. How can it have a square root and still be an integer? And the reason is this square root of 36 is perfect. It's a perfect square, so I know that this, right, is equal to negative 6, and I can see that this negative 6 would, in fact, fit into this. So I have to be careful not just, jumping on a square root, because if the number inside the square root is a perfect square and it can come out, right, it actually, the square root of the negative square root of 36 is negative 6, which is in fact a negative integer. Once again, if it's an integer, I go this way. It's also rational, and it's also real. But it's not whole because it's negative, and look at that list, they're never negative, and it's not natural because I don't count negative 6. So I'll probably ask you why in this one a square root, it had a square root sign, but it fell under the set of numbers an integer, even though it has a square root. And you would tell me the answer to that is because it was a perfect square, so it can come out of the square root sign. All right, now I need to draw something for you for extra credit. Oh, let's see, what shall I draw today? Today I shall draw I don't know. What shall I draw? I'll draw a blue ladybug. That's good. Yeah, everybody has blue ladybug. So I drew you a blue ladybug. What can I say, guys? There you go. 1, 2, 3, 4. I always try to get 9 spots on it because remember, 9 spots were lucky ladybugs in Charlotte's Web. All right, guys, that's it. Not too bad. Short video. I will see you tomorrow.